Hello. Today, guys, we're going to talk about Wednesday's due now, and then some of this weekend's homework. In fact, one problem, and that's going to be problem number 30 on page 33. Okay, but first let's look at Wednesday's due now. Abby walked with a velocity of 4 meters per second for 20 seconds. Oh, my mouse is just going all over the place. She then stood still. Now this is a very important part, guys. She stood still for 10 seconds. Sketch the DVT graph of her movement. Find her average velocity. Okay, so let's talk real quick first of what's going to happen. Now she's moving with a positive velocity for 20 seconds. And then after she does this for 20 seconds, she stands still for 10. Okay, so imagine this. Imagine yourself doing this, guys. You're going to walk forward for 20 seconds, and then you're just going to stop and stand there for 10 seconds. Now, you may want to initially ask yourself, what's the total time of this particular problem, of this story? Well, it's going to be the t, and I'll call it t subtotal, is going to be 30 seconds. And I got that from adding this value to this value. That would be 10 plus 20 gives me 30 seconds, the total time. So let's take a look. I have a graph over here. So remember, this is a d versus t graph. On your x-axis goes your d. I can't write over there. There is d, and that is going to be in meters. And then I have my t, and that's going to be in seconds. Now let's count these out real quick. I'm going to go 1, 2, 3, 4, 5. That's going to be 10. 1, 2, 3, 4, 5. That's going to be 10. 1, 2, 3, 4, 5, and that's going to be another 10. So as you can see, guys, I've made my time axis, my x-axis, 1, 2, 3, 4, 5, which is actually 10. 1, 2, 3, 4, 5, 10, and then 20, and then 30. Okay. Now, let's go back to the problem, though. So she's going to stand still for 10 seconds. Now, for those of you guys who remember your d versus t graphs the other day, here's a d versus t graph. If you stand still, your d versus t graph is going to look like this. So at the very end, these last 10 seconds, she's not going to move. So let's find out how far she moves in the first 10 seconds. So we have v equals d over t. Sorry, that's a very badly written expression, but hopefully you get the gist of it. Now, this formula right here only works for constant velocities. So if you have acceleration, which you will in your homework, this formula is not going to work. So let's just plug in our variables then. Let's pick another color. Let's go black. Let's go 4 meters per second, because that is our velocity. And this is going to be the time for our first 20 seconds. Equals, oh, that looks terrible, equals d, which is our unknown, over 20 seconds. So solving for your d, you're just simply going to multiply this 20 to get rid of it on this side, and you're going to end up getting 80 meters is our distance for this first 20 seconds. Now remember, the next 10 seconds you stand still, and we talked about that just a second ago. It's going to be a flat graph. So let's go back to our graph. Let's mark this up. Let's get a different color. Let's go to green. Let's go 1, 2, 3, 4, 5, 6, 7, 8. So each one of these is going to be 10. We can go, this is 20, 40, 60, and 80. And of course, this right here, this point at the very end, is 0, 0 for both of our axes. So now, we know at 20 seconds, we're going to be here. Did I do this wrong? I did. Whoops. Let's get the eraser out. I think this is the eraser. Yeah, that's the eraser. Let's get rid of this. Well, that was a mistake. Careful, guys. Now, once again, even Mr. Shaw, he makes mistakes labeling those axes. You have to be very, very careful. Just take your time. So, what we know is this. That at time 20, you are going to be right here. Okay? So, we'll just draw a line. All right, from there to there. Okay, great. Now, the last part of our graph says this, that for the last 10 seconds, you're not going to move. They stand still. So that means this last part just looks like this. And that's from the definition of what it looks like to stand still. Notice the displacement doesn't change. When your displacement from an object doesn't change, that means you're standing still. So this is what your graph is going to look like. Now to find out what your average velocity is going to look like, now that's another interesting question. And your average velocity starts right here and goes all the way, and I know I use a vector, it's not necessarily a vector, but that's how I get different colors. It goes from there to there. And if you could find the slope of this line, that will tell you what your average velocity is. So let's call that your average velocity real quick. This is average velocity. Actually, let's just be very mature about it. Let's use a v with a bar over it. So how could we find average velocity? Well, remember it starts at this point and it goes here. Well, you have 2 points. You have 80 and 30 here, and you have 0 and 0. So let's go down here. I think I have some space. I do. I can find the slope. Remember, slope equals delta y over delta x. And actually, I don't know why I'm not using my pen tool. Maybe that's why my writing's looking so bad. So that's going to be my, let's go up here, let's call this 0.1. It looks even worse. And this is going to be, let's call this up here 0.2. Okay. So now, remember delta is y2 minus y1 over x2 minus x1. And that is going to end up being 80 meters minus 0 meters over 30 seconds minus 0 seconds. And I'll leave you guys with calculators at home to solve that. But it's going to be 8 over 3 meters per second. And that will be your average velocity, because it is the slope of the average velocity line. Okay, now let's stop there, and I will make another video for your homework.